So we are doing a titration today. It's a redox titration. You're typically used to doing acid-base titrations, but if we're dealing with solutions, we can do a redox titration too. To start with, of course, we need a clean burette. So we get our burette, we rinse it the magic number 3 times, right? So when we rinse that, we spin our burette around like so, make sure that there is nice clean rinse water coming out through the eyedropper. Right, I like to then flip it over and rinse it out the bottom side to speed up. We do this 3 times. Then we rinse with a little bit of our solution. The solution we'll be using today is our 0.02 molar potassium permanganate. You'll recognize the permanganate from a few things, right? We've used that in a few other demos this year. The gun cotton one that I did the other day as a demo that popped pretty nicely, right? That permanganate is a strong oxidizing agent. It helps oxidize other things. And what we're going to be oxidizing today is an iron +2 solution. So this is our solution. It is iron ferrous sulfate, right? Fe+2 ferrous sulfate. We should have already read the directions on there, the ferrous to ferric titration by permanganate. I've got most of the stuff set up because I realized doing a lab is real different than watching somebody do a lab. So time-wise, I'm trying not to make this too long. YouTube cuts me off after about 12 minutes or so anyway. So we're set up with our burette. Now we need to get our Erlenmeyer flask set up. If we read our directions, it says that we need 15 milliliters of the permanganate solution, not permanganate, 15 milliliters of the ferrous solution. Amounts are critical here, right? Sometimes amounts aren't all that critical, so we can just estimate, or we can do a graduated cylinder kind of deal. Here, amounts are real critical, so we'll use a pipette. So we take it up past 0. I did not get it past 0, so I'm going to go ahead and use this for my 5. So I'll drain this down to 5 and then down to 0. Well, out all the way. This is calibrated TD to deliver. When we look on the pipette, we can see a TD on it. Right here on the top, there's a little TD. You'll either see a TD or a TC in that place all the time. Either calibrated to contain, like a volumetric flask, or to deliver, the way most pipettes are. Some pipettes are calibrated to TC, to contain, then you have to rinse those. So I prefer a to deliver pipette. I think they work a little easier. So I'll drain this guy down to 0 and then all the way out to 10. So this is only marked to 9.5. And then when you drain it the rest of the way, that's all the way to 10, right? So that's 15 milliliters of our ferrous solution. This is acid catalyzed, like a lot of our redox things are. You need some H+ around. So the directions tell us to get 5 milliliters of 3 molar sulfuric acid. I messed up the first time I was doing this titration and started titrating my extra iron solution. So I've already done this once and I've set things all over the place. But instead of titrating my Erlenmeyer flask, I was titrating my extra stock solution, and there was no iron in that, so I got a color change right away, and I couldn't figure out what was going on for a second, and then I realized talking while I'm doing labs does not make it easier to do the labs. So 5 milliliters of iron solution. Really, we could just graduated cylinder this, or probably even just guess at it, because the H+ is not really the thing that we're redox balancing and all that kind of stuff. What we're redox balancing is our Fe+2 to Fe+3 and our MnO4-. So -8 for our oxygens, +7 for our manganese. So +7 manganese is a purple, purple solution. And so as we titrate, the purple is going to go to an Mn+2. So it's going to go from +7 to +2. So that's an electron change that takes place there. And we will go ahead and reset so you can see the actual titration taking place. So my initial volume is right at 0. Remember, we want to take an initial volume. If you're down at like half a milliliter or whatever, we want to record that. As we add it, you'll notice the purple just instantly disappears. There's no purple left over. So I can go kind of quickly here at the beginning. just like I can with an acid-base titration. I will keep my flask under my burette the entire time. I'm never going to take the flask out to look at stuff. Let's see, can we see that pretty well? Yeah, so I'm never going to take my flask out from underneath, because if I go like this, now drops could go, and students will be like, yay, I didn't get those extra drops to make it turn purple. Well, those count in your volume, so I shouldn't just let those go. My purple's starting to stick around a little bit, so I will start slowing down here. Probably still go a little quicker than that. Notice I use two hands when I'm doing this. I can't see my screen, so I don't know if you can see my hands, but I've got one hand turning the stopcock on and off and one hand swirling. So I know most of you are pretty impatient too. So you don't want to lean on your elbows and all that kind of stuff. We want to do good lab techniques so we can titrate reasonably quickly. Oh, a little impatient there. I was trying to speed it up, but not that much. Okay, we are real close. If you look, that last couple drops, hey, there we are. Let's say those last couple drops are really hanging out there. So we've got a pink color that is persisting for 30 seconds. So we are good. So we went from an initial volume of 0. And now when I get my final volume, I'll put paper behind it so I can see it pretty well. We're right at 19. And then I actually want a darker colored paper with this purple in here. It's hard to see that on there. Okay, so it's 19. I would say 19.08. It is real close to 19.1. So 19.08 for our first volume there. I will do the other two off camera, so you're not staring at me watching me titrate. You don't really need to see me do that over and over again. And then I'll make a second video where I help you with the calculations. But I'll put the values on the Google Classroom and try to do those calculations on your own. At least do the pre-lab questions, like write a balanced redox equation and that kind of stuff, so you can start getting better at these calculations. And then use the second video that I make as a kind of a help sort of thing, right? That's that. So I got done with all 3 titrations and I started cleaning up and realized I should show you how to clean this up, because one of the things we can notice, permanganate is nasty. I don't know how well you can see that purple color in there, but permanganate doesn't rinse out all that well. So what I like to use is sodium bisulfite, not sodium bisulfate, but sodium bisulfite. If you watch as it goes through here, it will do that nice. It's taken Mn+7 to Mn+2, just like in the titration, and that purple is just kind of instantly gone there. We'll still rinse it out because the sodium bisulfite that's in there, but it's a great way to get rid of that permanganate, because that permanganate really stains quite a bit. So if I just dump this, I just like this, right? There was a ton of permanganate in there. I just left it in there so you can see it get chewed up. But it's a nice way to do that. And then we rinse everything and all that kind of stuff. But figured I should show you that for cleanup purposes as well.